Welcome to Flip Lesson 14 for the 5th grade. Today we're going to be looking at subtraction and understanding how to find missing numbers in subtraction problems. But before we get to that, we want to start to really understand how subtraction works and kind of look at some of the unique tricks that we see when it comes to the fact families of subtraction. We start on the left by looking at this problem right here. 78 minus 35 equals 43. And by doing that math, that is a correct answer. But the question would be, how do we know that we're correct? How do we know we did this problem the right way? And by checking our work, we're actually starting to understand how subtraction works and some of the neat tricks that come along with subtraction. Because 78 is our largest number, and we always subtract from our largest number when it comes to subtraction, we know that if we were to basically reverse this, that our other two numbers added together would actually work to help us check our answer. So in essence, we're taking this 43, we're going to add it to the 35, and it should equal 78. And so let's see if that works. I'm going to move this to a vertical setting like this, and we'll see if we get 78 as an answer. 3 plus 5 is an 8, 4 plus 3 is a 7, and as we look at our work there, we see that, yes, it is correct in that way. And so as we went from left to right to solve the problem, 78 minus 35 equals 43, now we can go right to left to check the problem by switching the symbols. As we come over to our second example over here, we see that 65 minus 23 equals 42. And the question might be, well, is that true? Well, let's see if our work is correct. And by using a similar method of what we did before, we can look at this, and we really can just work backwards to see if 42 plus 23 is going to equal 65, right? And so if we were to leave it in this setup, we're just going to work backwards. 2 plus 3 should equal 5. 4 plus 2 should equal 6, right? And we can see this working that opposite way, that is definitely true. And so we added here, and that should equal 5, and we added here, and that should equal 5. And so what we see here is, as we look at a problem that's in the horizontal plane like that, so we're going from the left to the right to solve it, then we're going to go the opposite way, right to left, to check it, and of course changing those symbols. Compared to on the right side where we're going the top to the bottom, then of course we reverse that, we can go bottom to top to check it. And so we have those very unique directional things that come along with subtraction. Now, these principles are going to help us find missing numbers in subtraction. As we have this problem of g minus 22 equals 31. Now, we don't know what g is, but what we do know is that because the g is our topmost number we're subtracting from g, that will be our largest number when we're done. So what we need to do is we just need to reverse this. And so we have our 31. I don't want that line there, right? We're going to do 22, and now we're going to add. We're going to add these together. So whether you rewrite it like this, or if you keep it in your original form, and since our subtraction problem is going down, to solve now we can go up and change this into addition problem. So 31 plus 22 should give us our answer for g, or what this missing idea is, which represents our g. So if we add 3 plus 2 is going to give us 3, and 1 plus 2 is going to give us 3, and 3 plus 2 is going to give us 5. We now have 53 for our answer for G. I'm going to write that down over here so we don't forget to write that. But now we can, of course, check our work by going back down. And so we can erase our symbol here and now make this a subtraction problem. I'm going to erase this line here, get rid of this line here quick. And so by subtracting 53 and 22, I should get an answer of 31. 3 minus 2 equals 1, and 5 minus 2 equals 3. And so I know for sure that G equals 53. Of course, it's not always that simple. And sometimes we have to look at this in a different way. 62 minus n equals 47. If we were to try and subtract down, of course we can't because we have that n there. If we try to add back up, our new problem becomes 47 plus n is supposed to equal 62. And both ways you can see that we have a number in there that's missing and we don't have an actual variable to help us, this variable out of there to be able to solve. But what we do see now is that with our new problem, we have something we've already covered by looking at missing numbers in addition. And we already know how to handle this. Because this is our total, we know that that is going to be our largest number. And so I can put that 62 there. And that means n and 47 are going to be smaller numbers than that 62. And so I can place the 47 here, subtract, and that will equal n. And so let's do the work here and see how that goes. And so 2 minus 7, can't do that, so we're going to borrow from the 6. That's going to become a 5. Our 2 is going to become a 12. So 12 minus 7 equals 5. 5 minus 4 equals 1. So n equals 15. And of course, we can double check our work by going and plugging it into either one of these problems and seeing if it works out. All right, I'm going to go back to the original problem. And I'm going to go 62 minus 15, and that should get me 47. And so 2 can't go into the 5, so I'm going to borrow from the 6 again, and I'm going to get a 5. And this 2 becomes a 12. So 12 minus this 5 is going to give us a 7, and 5 minus 1 is going to get us a 4. And so by checking my work, I see that 15 is definitely equal to n. And so sometimes as we get missing numbers in subtraction, like over here, we can see that we can just use the rules of the directions, going up and down to help us find that missing number. While other times, like this example over here, we can see that because that missing number is in a place that doesn't allow us to use this up and down right away, by transforming it into an addition problem, we can now use the pattern that we've already covered and realizing that our total is going to be the larger number on top here, and we're going to subtract the other number to get our missing add-in. And so we rearrange 2 times to help us solve that problem. And that's what we want to look at when it comes to missing numbers in subtraction. Understanding this principle of how subtraction works in one direction and checking the answer works in the other direction, and then we can apply that to finding missing numbers in subtraction. Then I will leave you with a couple sample problems, and you can work on those as you prepare for this lesson. That's the end of lesson 14.